This next function is a rational function. We know that it's a rational function because you can see that in the denominator, it has an expression of z. So we're going to use here the rule intended for differentiating a rational complex function. Take note, our function here is identified as 1 over z cubed plus 2. Unlike polynomial functions, where you can just simply distribute or apply the sum and difference rules, distribute d over dx to all the terms and solve them independently and then combine later on. Here, we're going to use this rule, k of x, if it's a combination of m of x and n of x. By the way, we're using x here. That's for real numbers, but this is even possible and applicable as well for the complex numbers. So the derivative of that, you can of course change that to z if you would like to. This is the denominator times the derivative of your numerator minus your numerator times the derivative of your denominator all over the square of whatever your denominator is. Looking in our given function, this is our denominator, and we are lucky to have a numerator which is just equal to 1. So applying that here, the first derivative of our function here is the denominator, z cubed plus 2, times the derivative of 1 is obviously 0, plus, minus, my bad, minus your numerator, and then the derivative of your denominator, which is z cubed plus 2, is equivalent to the derivative of z cubed plus the derivative of 2. The derivative of z cubed is 3, z squared. The derivative of 2 is 0. So basically, it's just 3 z squared. So this is the 3 times, 1 times 3 z squared, all over your denominator, which is z cubed plus 2 squared. Okay? Now, how do we find the final answer? So simply try to simplify all the necessary items here. So you will have 0 times the entire binomial expression is just 0 minus 3 z squared, all over the square of your denominator as it is. Now, some references would like to expand whatever your denominator is. Of course, you can have here what's the expansion of that. So you have, say for example, z cubed plus 2 squared. So the square of the first term, that's z to the power of 6 plus twice times z cubed times 2 is actually, okay, let me do it step by step. So you have twice z cubed times 2 and then plus the square of your last term. So z to the power of 6 plus 4 z cubed, and then you have your plus 4. So that means that this is our equivalent form for the denominator. However, there's no need to do that because our numerator is just negative 3 z squared. So nothing can be simplified if we're going to use the rest of the terms here. Right? So why not, for some references, they would like to stick to whatever is given as a binomial expression unless there are possibility for it to be simplified. So even, don't use that anymore, or if you would like to, just stick with whatever given here, z cubed plus 2, or the square of that. This is now the derivative of the given function, which is identified as a rational expression, 1 over, you will have here z cubed plus 2. Take note, it is negative because it is the result of your numerator. Okay, so this is the answer for this item. Thank you very much for watching.